Hi students, welcome to YourPedia education and welcome back to the NPTEL questions module for electrical engineering branch. So in this session we are going to start another question of power electronics subject. So and the question number is 183. Question number is 183. So this is the NPTEL book YourPedia education is providing to the students. So along with the video solutions. Now let's dive into the question number 183. So what is the question number 183 is, it is a single phase fully controlled bridge converter which is given which is supplying a inductive load. Assuming that the output current is virtually a constant value and is equal to 6 amperes. So the load current is 6 amperes and it is of constant in value. Determine the following performance measures, especially if the supply voltage is 230 volts is given and 50 Hz is also given as a supply frequency. Firing angle here mentioned it as 30 degrees. He is asking us to calculate the performance parameter, that is percentage THD. Percentage THD. So if you take the percentage THD into consideration, so what is the meaning of percentage THD? It is total harmonic distortion. It is total harmonic distortion. So what is the definition of total harmonic distortion? So in some textbook this will be given as distortion factor also. So what is this one is square root of source current RMS square value minus fundamental value of source current RMS square with ratio of fundamental RMS square value, with the ratio of fundamental RMS square value. So first we need to calculate the source current RMS value, then we need to calculate the fundamental source current RMS value to answer this question. Now let's analyze the circuit and let's draw the source current waveform first. Later we'll discuss the calculation of percentage THD. Now first let me take the single phase fully controlled bridge converter circuit. So this is the single phase fully controlled bridge converter configuration. So this is the circuit, and what type of load he has given? A constant current load he has given. How much amount of constant current it is supplying? 6 amperes is the load current. So this is a phase control rectifier, so it will have SCRs and the source is sinusoidal. So like this, source is sinusoidal and this is the source voltage and this is the source current direction. Now this is T1, T2, this is T3, T4. So T1, T2 will turn on simultaneously and T3, T4 will also turn on simultaneously, but this pair and this pair will turn on in complementary fashion. When this pair is in on state, this pair will be in off state. When this pair is in on state, this pair will be off state. So this is what the question, and no need to worry about the output voltage waveform and all. So here we need to focus only on two waveforms, because two waveforms we already know. What are the waveforms we know? One is supply voltage, we already know that. So what is the supply voltage? It is a sinusoidal voltage, and this is the sinusoidal supply known value of voltage. And what is the second known parameter we know from this circuit is, second parameter is your load current. So if you observe the load current waveform, this is the load current waveform. This is the load current waveform. How much it is flowing? 6 amperes. 6 amperes. This is the circuit. Now let's draw the source current waveform. Now from where to where will give you triggering pulses means we are giving triggering pulses for T1 and T2 in this time period. So here we'll give the triggering pulses for T3 and T4. So when we give triggering pulses to T1 and T2 and T3 and T4 during these periods, what will happen to the turn on status of these devices? They will turn on. So from alpha to, this is alpha, this is pi plus alpha, this is 2 pi plus alpha. So again you will have 3 pi plus alpha here. So from alpha to pi plus alpha, which devices will be in on state? T1 and T2, because at pi devices T1 T2 will try to turn off, but load requires a constant current. So where T3 is T4 is turning on, T3 T4 is turning on up to up at pi plus alpha. So from pi to pi plus alpha you don't have a provision to supply the load current requirement. That is the reason this load, constant current load or a highly inductive load, will force the devices T1 T2 to stay in the on state, to maintain the on state. This way load will force the devices T1 and T2 to maintain its on state or to stay in the on state, so that the load will get the required amount of current. So that is the reason. So the source will get, or the source current will be flowing from, means load current is flowing from source current, through which path when T1 and T2 are turned on, source current will be like this and load current will be supplied by the source in this direction. So I can say that source current is equal to load current, because the direction of source current and the load current both are in same direction. So when T1 and T2 are turned on, so what happens to the voltage, what happens to the currents? Both current, load current and source current will be in the same direction. So that is the reason you will get a 6 amperes of positive value of current here. Now at pi plus alpha T3 T4 are turned on. Once T3 and T4 are turned on, what happens to the current flowing through the T3? This is the current flowing and this is the direction of load current requirement which is satisfied. This is the T4 current, as it is a unidirectional device. So from T4 current will flow through the source like this. Now tell me, this is the load current, this is the load current or actual current flow. That is the reference direction of current flow of your source current, but actual current is opposite to the reference direction. So how we can write this one? In this case, means in the second case, the source current is negative. Source current will be negative. So how much value it is negative means it is same as load current, but negative value we will get like this. Again we will get the positive value like this. Now what type of waveform it is? Square waveform, but there is a small delay in the angle. So that delay is alpha. That delay is alpha. Now we know the Fourier series for this square waveform. We know the Fourier series for this square waveform. What is the Fourier series for this square waveform? Square waveform Fourier series will be, what is the peak value will get? The peak value will be how much? 4 I0 by n pi will get 4 I0 by n pi, but it is a fundamental. We'll get this as pi. We'll get this as pi. So what is the peak value of fundamental current? I01 maximum, which is equal to 4 I0 by pi. But what current we require for calculation of THD? We require fundamental source current RMS value. But here we got a maximum value, that too sinusoidal value. So what is the value of fundamental source current, RMS source current value? Which will be the fundamental source current maximum value divided with root 2. So what is the maximum value we got? 4 I0 by pi. So you will get root 2. So this becomes 2 root 2 by pi. 2 root 2 by pi I0 we will get. And as it is a perfect square waveform in between alpha to pi plus alpha to 2 pi plus alpha. So what is the RMS value of this square waveform? RMS value of square waveform is same as the RMS value of your, or peak value of the square waveform. So RMS value of source current, RMS value of source current IS, which is equal to peak value of your current, which is equal to 6 amperes, which is equal to 6 amperes. This will be 2 root 2, that is 0.9 into 6, 0.9 into 6. 9 6 9 5 is 45, 9 6 is 54. So this will be 5.4 amperes. This will be 6 amperes. Now let's substitute these two values here. So if you want percentage THD, just you need to multiply with 100. Just you need to multiply with 100. That's it. So what is the percentage THD value we'll get? The percentage THD, which is equal to square root of 6 square minus 5.4 whole square divided by 5.4 square, which is equal to multiplied by 100 multiplied by 100. Square root of this will be 5.4 whole square, this will be 5.4 whole square, 6 square. Numerator part will be like this, 6 square minus 5.4 square. So this value is 6.84 you will get, and what is this value will get? Only 5.4 square, it will be 29.16. 29.16 you will get this value, 29.16 multiplied by 100. So what is this value? 6.84 divided by this one, and square root of answer will get as 0.4843 multiplied by 100. So this will become 48.43 percentage. So this is the actual percentage of THD, but the allowable percentage value of THD is how much is the maximum allowable THD according to the international standards and Indian standards is, if you take the international standards, that is IEEE standards, so this value will be less than 5% is the allowable range, but according to the Indian standards, it will be less than 6% is allowed. But how much percentage you have? 48.43. So why you got this kind of waveform is because of the presence of a square waveform in the current. So to avoid this one, we will go with the filters. So THD, total harmonic distortion, this is harmonic, it is creating or it is producing the harmonics in the system, in the existing circuit, so which will reduce the performance of our converter. So how it will reduce the performance of converter means, so as the distortion is more or the harmonics are more, because if you observe the current waveform, so what is this current waveform? It is sinusoidal, this is fundamental current waveform we got, but this square waveform will have different harmonic components also. Fundamental it will have, third harmonic it will have, fifth harmonic it will have, seventh harmonic it will have. So each and every harmonic will introduce some torque. So there might be some torques will be opposite to the original torque, and some torques will be in the same direction of the same original torque. So which will create as external some other extra problems in the system, which can be avoided by using your filters. So that is the reason source filter is required at the source side, and load filter is also required at the load end. Because what is the output voltage you will get during this condition means, if you draw the output voltage, which will be same as the supply voltage like this, so you will get output voltage like this. So is it pure DC output voltage? No, right? So here also you are getting a output voltage. The output voltage contains a harmonic components. So these harmonic components should be removed by using some external filter requirement. So these performance indices will decide what we have to do in the further stages. Yes. So that is the reason we'll connect a capacitive filter to reduce the voltage ripples and inductive filter to reduce the current ripples. So if you reduce the voltage ripples and current ripples, which will be mostly nearer to the DC side, if you take a DC load side, and it will be pure AC waveform if you take on a AC side analysis. Okay, so this is how we need to analyze and solve these kind of questions. Thank you, all the best.